Hello class, I just wanted to walk you through worksheet C.4.2 Avogadro's hypothesis. So when you get it, it'll look like this. You'll have a hard copy though. I'm just doing this video on my computer. You'll answer that question right there. You'll read this. The stuff that you read is very important to be able to complete this. It talks about Avogadro's law, who worked on built off the conclusions of Guy Lussac. But what I'm going to do is basically what it says is it says equal volumes of gas must react to form equal volumes of product. And so therefore, if I react one volume of one substance, if I have one volume of one substance, one volume of another substance, then I have to have one volume of product. And so I'll show you what that means here on this example. So if I double click here, I've got hydrogen plus oxygen produces water. So basically what it's saying is I've got two volumes of hydrogen, one volume of oxygen, and that's going to produce one volume of water. And so what I'm going to do is I'm going to make my hydrogen atoms. So I'm going to just do that, and I'm going to make them red. Doesn't really matter. And I'm going to go just Control V. Now, you could put however many hydrogen atoms in this box as you wanted. So like if I wanted to put 5 in this first box right here, that's okay, but what that means is Avogadro's law is saying equal volumes, which means that if I have 5 particles in this one, I need to have 5 particles in this one, which is going to have 5 particles in this one, which is going to have 5 particles in this one. If I have 1 particle, then that means I need to have 1 particle, 1 particle, 1 particle. And so that's completely fine, and this is actually a little bit easier for me, so I'm just going to do 1 particle so I don't have to draw 5 of them. If you wanted to do 5, you could. Then I'm going to show my oxygen, and I'll make it a little bit bigger, and then I'll make it blue. Just like so. So right now, we're satisfying Avogadro's law by saying 1 volume of hydrogen, 1 volume of hydrogen, 1 volume of oxygen. Then I'm going to make 1 volume of water. And so I'm going to make it as a compound. And so when I do that, the key thing is I need to combine these guys in a way that's going to make 1 compound. And so as you can see, this is, or excuse me, 1 particle. It's going to be pretty easy, and I'm going to go ahead and make it like the Mickey Mouse way, like so. So there's my water. So now I've got the following: hydrogen, 1 volume of hydrogen, reacting with 1 volume of hydrogen, reacting with 1 volume of oxygen to produce 1 volume of water. Now, if you did 5 here, 5 hydrogen in this box, you need to show 5 hydrogen in that box, 5 oxygen in that box, 5 waters produced. Okay? So you guys can do that 2 through 4. Then when you get to number 5, it gets a little bit different. And so the rule stays the same, that equal volumes have to be in here, but now we're dealing with hydrogen reacting with chlorine, and in this case it's telling us that 2 volumes must be produced. So 1 volume of hydrogen plus 1 volume of chlorine will produce 2 volumes of hydrogen chloride. And this is what, if you did this experiment in the lab, you would actually see this. And so therefore I'm going to make my hydrogens like so. Oh, I guess I only wanted 1. And then I'm going to make my chlorines like so, make it a little bit bigger. I'll make it blue. Then I'll come over here. Then it says hydrogen chloride, and so therefore I've got to put that there. And I need 1 volume of, so I've got 1 volume of hydrogen reacting with 1 volume of chlorine to produce 2 volumes of hydrogen chloride. And so hydrogen chloride, as you could probably guess, is just hydrogen and chlorine compounded together, like so. So I've got that for hydrogen chloride. However, there's a problem in that I didn't create 2 volumes, and so I need to have 2 volumes here. And so I'm just going to Control C, and then I'll Control V that, and then I've got it. So now Avogadro's law right now is satisfied. I've got 1 volume of hydrogen reacting with 1 volume of chlorine to produce 1 volume of hydrogen chloride and 1 more volume of hydrogen chloride. But there's a problem with this. Perhaps you can see it at this point. These guys are not satisfying the law of conservation of matter. I have one hydrogen, and then after I've run my reaction, I have two hydrogens. I've created a hydrogen. Same thing with the chlorine. I started with one chlorine. At the end, I'm going to end up with two chlorines. I've created a chlorine. So how could I change my before picture to be able to satisfy the law of conservation of matter, but still satisfy Avogadro's law? So what I could do is I basically need to have another hydrogen in here. So would this be okay? Well, yeah, for the law of conservation of matter it would. However, it would not satisfy Avogadro's law, because Avogadro's law states that equal volumes of gases produce equal volumes of products. So what that means is I've got one particle here, one particle here, one particle here. This has to be one particle. Well, how can I make two different elements one particle? You've got to touch them. Just like that. And so now, that is one particle because they're connected together. But still, you have two of them. And so that's satisfying the law of conservation of matter. This guy, same thing. You have to do the exact same thing. You can't put them over here because that doesn't satisfy Avogadro's law. You've got to touch them. Like so. I did a little bit of overlapping. There we go. Oh. Yeah, whatever. Okay, so one particle, one particle, one particle, one particle. Avogadro's law satisfied. Two chlorines in the product, two chlorines in the reactants. Law of conservation of matter is satisfied. For the hydrogen, same thing. Two in the reactants, two in the products. Therefore, both the Avogadro's law and the law of conservation of matter is satisfied. So, what we've just given proof of is the presence of something called diatomic elements. And what diatomic elements are simply elements like hydrogen and chlorine that when they're by themselves, they are paired together with another one of their nature. So for instance, hydrogen in nature is always paired up with another hydrogen. If it's a straight hydrogen, it is H2, or two hydrogens connected together.